Hello and welcome. My name is Henry and today I'll be going through a tutorial on how to create the Pong game in the Teensyduino environment using an OLED screen. This will hopefully be part one of a longer project documenting the process of creating a full retro games console using the Teensy. This video will focus on prototyping the electronic hardware required and writing the code for Pong. So I'll get straight into it and I hope you enjoy the video. First things first, I want to design the circuit and get my head around what components I need and how to wire them. To do this, I'm using Inkscape, which is a free program. It's not really an electronics program, but it's fine for a visual representation. I've taken the Arduino image from their official website, and the first components I'm creating are two potentiometers that we will be using with the Teensy. A potentiometer consists of a resistive strip with a tab on it, and as the tab moves along the resistive strip, the output voltage will change as a ratio of the input voltage. We need power to one pin and ground to the other, and the central pin carries the resultant signal that can be wired to any of the analog pins of the Teensy. Once we have created those, we can start to create a representation of an OLED screen. So I'm going to knock together something that looks vaguely like our OLED screen, and this particular OLED screen that we're using has 4 pins: ground, power, SCL and SDA, which make up the I2C protocol to communicate with the Teensy. SCL and SDA have 2 predetermined pins on the Teensy that we have to use, and ground and power can go to any ground and power pins on the Teensy. It is worth noting that as I make this diagram, I may not stick to exactly the pins that I'm using here. I'm just getting a vague idea of what I need to use for the final circuit. Next, we can put together 5 push buttons. As well as having the Pong game running on the Teensy, these buttons will allow us to have a menu that can be used to alter game difficulty and other configuration options, whilst keeping options open for other games that could be run on the hardware, that require buttons such as Snake, for example. These buttons have power to one pin and earth through a pull-up resistor to the adjacent pin. The opposite pin to the earth pin is the signal pin, which can be connected to any digital input pin of the Teensy. This results in a digital 1, in this case 5 volts, at the pin when the button is pressed. And that is our completed circuit. The Teensy will come delivered with header pins that need to be soldered into the board. Here I'm using a piece of breadboard to hold the pins in place whilst I do this. And you can see that I've not soldered the pins, the vertical pins in. That's because in breadboards like this one, the vertical pins wouldn't fit and we don't need them anyway, so I've left them out. When the Teensy arrives, it will come preloaded with the blink program. So all I'm doing here is plugging the Teensy in and making sure that it blinks. So we've got a blinking light, and now that we've got that, we can start wiring in some of the hardware. The first thing I'm going to test is the screen. So here I'm plugging it in using jumper cables. And now we can move over to the computer to write a program. So in order to test the screen, the first thing you want to do is open up your Arduino software. If you don't have this installed, just go to the Arduino website and download it. Now because we're working with a screen and communicating it to it through I2C, really we want to use a library to help us communicate with the screen so we don't have to worry about that side of all the coding. So to get this library, you go to Sketch, Include Library and Manage Libraries, and simply search when it loads for U8G, and U8G2 is the library we're using. You see I've already got it installed, but if you don't have it installed, just select it here and click install. U8glib is an old version of this library, but it got updated recently to work with a lot more hardware. So the old version does not work with the Teensy microcontroller using hardware I2C. Once you have the library installed, the first thing, because we're testing our screen, we'll go to the examples and scroll all the way down to the bottom to find U8G2, and then we'll use the Hello World example just to test our Teensy. Our screen, sorry. So the first thing you'll need to do in here is find your screen in this list and how you're communicating with it. So in my case, I'm using a 128 by 64 screen, and it's using I2C hardware version. So this is hardware I2C. So I will uncomment this line, and that will allow me to communicate properly with the screen from my Teensy. Everything else should be fine. It's simply, all this program does is it begins the library, clears the internal memory, selects a font, writes a string into the internal memory, and then sends that internal memory to the screen every 1000 milliseconds. So then we can verify this and then upload. And there we have it, a working screen. You can see the Hello World text printed there on the bottom of the OLED, which is great. And now that we've got that, it's time to wire in the rest of our hardware. So first I'm just creating a power rail and a ground rail on the top of our breadboard. Then I'm connecting our buttons to ground, or one side of our buttons to ground, through a resistor. Each resistor is a 10 kilo ohm resistor. And once I've done that, I'm going to connect the other side of the button to power. It's not shown in this video, but after having done this, I connect the top left-hand pin of the button to the corresponding pins on the Teensy, as you can see it's shown here. And now that I've done that, I'm going to wire in the potentiometers. So as we said earlier, the potentiometers have the far left pin to power, the middle pin to an analog pin of the Teensy, and the far right pin to ground. Now that we've done that, the last thing we need to do is bridge the power rail and the ground rail on the top of this piece of breadboard. Most breadboards in this style come with a kind of split in the middle, so you can have separate ground rails and power rails if you need them, but we don't, so we'll just connect them as you can see here. Now that we've wired up the buttons and potentiometers, we really need to test them to make sure that they're working properly before we try to implement them into our main Pong code. So I made this little Arduino sketch just to test the buttons and the potentiometers, and also test the screen at the same time to make sure that we can update it in real time with information just by putting together this little sketch. So this is available in the description. If you look, you can download the sketch, or you can just write it yourself from what you see here. I'm going to quickly explain what everything's doing, just so you have a vague understanding of what's going on. So we're just including SPI and wire libraries so we can communicate with the screen. Well, the SPI one we don't actually need, but we need the wire library for hardware I2C. We're creating some integers, so button 1, button 2, button 3 are connected to pins 10, 11 and 12 of the Teensy, and the potentiometers are connected to analog pin 1 and analog pin 0. Then we have some variables, so when we read a value from the buttons or the potentiometers, we store them in these integers. And then we need to convert those integers to characters in order to display them on the screen, so we create some characters to allow us to do that. You've seen this before. This is selecting the correct screen. I've deleted all the others from the list. Again, the setup, we're beginning the library here, and then selecting input pin modes for all of the pins that we've already defined. Then we get into the main loop of the code. Button 1 is being digitally read from the button 1 pin, so we're storing that So this is the pin, and this is the integer that we're storing the result of the digital read in. The same for the potentiometers, but with analog read instead, because we're reading an analog value. Then we're using itower, which is a little function that will convert an integer into a character. 10, the 10 at the end is simply saying we want to convert in decimal. We're doing the same thing for the buttons and for the potentiometers. Then clearing the internal memory, setting the font, drawing a string at the top that says testing, drawing some more strings of the button character and then of the potentiometer characters, then sending all of that buffered data to the display every 10 milliseconds. So it should be updating as we press and let go of the buttons or whatever. One thing to note is that when you're drawing a string using this library, the two numbers at the start are the x and y coordinate of the bottom left point of that text. So that's why those numbers are what they are, and you'll see where that places them on the screen in just a moment when we upload this. So as you can see, we've got our 3 buttons working. As I press each button, a 1 is displayed on the screen in the correct position, and as I turn the potentiometers, the analog value read from them differs between 0 and 1024. Now that we've tested all of our hardware, it's time to bring it all together and write our Pong code, or have a look at the Pong code that we've written. So, just to credit the original creator of this code, it was created by Tom Igo in 2012, and back then it was kind of a Pong code written for Arduino using an LCD screen. That code was then modified by Scott Fitzgerald, and then in 2015 I modified it to work with an OLED screen, and then in 2017, more recently, I updated it to the new UHE2 library and made it compatible with the Teensy. And it's undergone quite a lot of changes since its original version. I'm only going to kind of glance through this code very quickly in this video as to not take too long overall, but I may well release another video that goes into more depth on this code if people are interested in that. So to kind of quickly go through everything, obviously we include the Arduino library and the UHE2 library, and then we're using hardware I2C, so we include the wire library to enable us to do that. This is our screen, as we mentioned earlier in our test code, and then we have a bunch of integers and floats that are being used for kind of pins, positions of different objects on the screen, the width and height of the screen, the position of the ball, and then these integers are used for kind of control and score and things like that. We begin the library, and we're making our buttons inputs. We're only using 3 buttons for now. Obviously we will need 5 eventually, but for the time being, just because we're testing, only 3 buttons. So now the main bits of code are kind of split up. So we have a function that will deal with all of the actual kind of maths that's going on in the background, and then a function that will deal with drawing information to the screen for every different situation. So there's one for the main menu, one for the Pong menu, and then one for the game itself. So 2 for each. So as you first load up the program, you'll enter, well obviously you do the setup first and then you enter the loop. So what the loop will do is instantaneously it will call a draw menu, the draw menu function, which is down here. That sets the font, says menu, select game, Pong and Snake, and depending on where your kind of cursor is, the cursor is controlled by N, whether it's on Pong or Snake, we'll draw a frame around that selection to let the user know that that's what they're looking at. So this loop keeps running, and it keeps calling that every time it runs at first. It's digitally reading the 3 buttons, and if either the up button or the down button is pressed, the value of N changes, moving the selection from either Pong or Snake. If the center button is pressed and N is 0, meaning we're selecting Pong, then we go into the Pong menu. If N is 1, then we would be going to Snake, but for now obviously that isn't there, so we'll just do nothing. And that's kind of how the menus work, and the Pong menu functions in very much the same way. Reading the buttons, and then we have different things that happen depending on which button is pressed. Now up button and down button change the value of N, and then depending on the value of N when the center button is pressed, something different will happen. So the first thing is we'll start the game. The second selection changes the difficulty between being easy, medium, hard, and incremental, and I'll explain that in a minute. But the different difficulties essentially just change the X and Y velocity of the ball, and we'll see how that changes how the game actually works later on. And then there's a menu button that takes you back to the main menu, which just resets N and S, and also calls loop. And then drawing the Pong menu, we've got Pong, start game, difficulty, and then a string that will change depending on which difficulty is selected, and then back. Once again, drawing frames and moving the frames depending on which value of N we have. So the game itself, this is kind of the background code that actually runs it. We have two paddles, which are analog read from the potentiometers, which are then mapped from a value between 0 and 34, which places them on the screen somewhere from the bottom to the 34th pixel up. So kind of that maps the entire range of the potentiometer to the entire range of the part of the screen that we're using. If the ball goes further to the right than the kind of the edge of the screen minus 3 pixels, then the left player has scored a point because they've gotten the ball past the paddle. And we reset the ball in the center position and restart the game after a delay of 300. The same for the right player if the ball goes all the way to the left hand side of the screen. This little if statement here says if the ball exceeds the either top or bottom of our working area of our screen, then we inverse its direction in the y-axis, so it bounces. This statement is for if the ball hits paddle A, so if the position of the ball becomes greater than either side of the paddle, then it will bounce off the paddle, changing the direction. This little if statement here is for when incremental difficulty is enabled. Every time the ball bounces off a paddle, it will increase its speed by 0.1 pixels per refresh, which is how the whole system works. And then this is the same piece of code, but if the ball hits B paddle. So then we update the position of the ball. So ball X and ball Y is the position of the ball at the current time, and we essentially add on the ball direction. So if ball X is at pixel 15 and it's moving at a speed of 1.25 pixels per refresh, it will go to 16.25 next time. So then at the end of this Pong statement, we will call the draw Pong function in order to kind of draw all the new information that we've calculated using this code on the screen. And this code all keeps running because of this while statement, so while m equals 1, and m is only set to 0 if a player wins. So you can see that down here. So we're setting our font, drawing Pong at the top of the screen, a dash, and then the score of each player. X and Y is the score of each player. And then we're drawing a paddle here, and the ball here. So we're plotting the X and Y coordinates of the ball. If one of the players' scores exceeds 5, then we draw left player wins on that screen and reset all of these values so that one player's score, the other player's score, and the kind of integer that keeps the while loop running, and we go back to the main menu. So that's the general idea of the whole code. As I say, I've kind of tried to glance over this quickly, but hopefully that gives you a good solid understanding of what things do. And if you are interested, there's a lot of things in here that you could mess around with and change to kind of change how the game functions. It's one of the reasons why I did the incremental difficulty, just to point out things that you could add, like ways you could modify the game. One other thing I was thinking of doing was changing it so that each time the ball hit the paddle, you could add like a random chance that it would change its Y velocity ever so slightly to make it less predictable where the ball's going to go next, to make the game even harder in the higher difficulties. Right, well, thank you very much for watching. I hope you've enjoyed this video and that you've learnt something as well. In the future, I'm hoping to continue this project, and the next step would be to make a case to house the system, creating a proper portable games console. So, once again, I hope you've enjoyed, please leave a comment of your thoughts and any feedback you might have. This is the first time I've tried documenting a project like this, and I feel like I've learnt a lot from it, and there are things that I could have done better, but I'm keen to keep going and try again. So, see you soon.